Okay, for this assignment, you're gonna start out by plotting our t and x. Now, if yours doesn't have this written in, this is a 9, this is a 0. So go ahead and take these values and plot them on this graph. And then go ahead and pause the video and get that finished. All right, now that you have your xt graph done, you're going to go ahead and convert to the vt graph. I do want to point out that the 0 line is here, because you will have some values that end up being negative, so you need your 0 to be in the middle. So in order to get your velocity, we know that our velocity is the slope of the xt graph. So you're gonna go ahead and take and figure out the slope for each section and then plot it over here. So for instance, this first one, we've got 2 seconds and we went 4 meters. So we've got 4 meters divided by 2 seconds is going to give us 2 meters per second. That's for the first 2 seconds. So I'm going to come over here and I'm going to figure out my 2 meters per second. And I'm going to plot the first 2 seconds at 2 meters per second. Go ahead and do the same and figure out your slopes for each of the time frames and plot them over here. And then pause the video and go ahead and start it back up when you're done with that part. All right, after I made a couple of errors myself because I extended this one an extra second, which then messed me up on this one. You should have something that looks like this. Now keep in mind this last stretch, because it's going downwards, it is a negative slope. So make sure you reflect that that is a negative on the graph as well. But just for the example, we're going at -10 over a matter of 2 seconds. So we end up with -5 meters per second for that one. Okay, if you have any questions on how the rest of these were calculated, let me know. I'm hoping you don't have any issues with calculating that slope. Okay, so determine the average velocity. So average velocity, you need to show your work. Remember, average velocity, we don't care about the total distance we went. We just care about where we started, where we ended up. So where we started, where we ended up, think about what that changes, and then go ahead and calculate your average velocity. If you have questions, let me know. And then on the VT graph, you're going to calculate the area for the 3 to 5 seconds, which is going to be here, and the 7 to 9 seconds for the next one. Okay. So for these two problems, you're calculating the area for these two. When you're calculating the area, I want you to keep your labels with it. So this one's going to be 3 meters per second for the height. You're going to multiply by 2 seconds because it went from 3 to 5, so that's 2 seconds. So you're going to end up with 6 meters because our seconds cancels. Go ahead and do the same thing for this one, but for these 2 seconds of time. Okay. And then when you come to the back, describe how the total change in position for the object can be determined or verified from the velocity and time graph. Okay. So what can you do to determine the change in position? So what did we do on the previous page? And then how should the total change in position compare to the XT graph or the data table? So when you're looking at the XT graph, how should that change in position reflect on your graph? So if we start at 0, your total change in position should go up whatever that area is, correct? And that's what we're looking at for that one.